Solid liquid separation in swine and dairy operations for Animal Ag class. Today we'll be discussing the methods of separating solids from liquid and manure, also the benefits, and then how it can be applied to swine and dairy, and finally, new research that is being conducted in this field. Traditionally, this has been done through sedimentation, so simply letting gravity do its work. For example, in the picture you see that the waste comes in and it actually flows down the concrete panel. As it does, the solids get separated out and are pushed into the manure pile down at the end. This is how our system at the Virginia Tech Dairy works. Other options, though, include dehydration and evaporation, but this takes a lot of heat and a lot of time, which most areas can't provide. And then a newer area is actually using coagulation of what is called flocculants. So those might be aluminum ions or a natural material, even some bacteria can do the job, and then allowing it to settle out afterwards. Additionally, though, there are many mechanical options. As you see here, we have a screen. The water pours in from the top down over the screen and then out the tube, and then the screen is cleaned to remove the solids. There's other options, for example, spinning the material very quickly in a centrifuge, or having actually a belt press and pushing the water out, even having a screw and spinning, or simply allowing it to roll along and it drips out as it goes down the ramp. But besides the ways that it's done, there are reasons and disadvantages for using these systems. One advantage is for the environment in that oftentimes manure is high in phosphorus, but that may not be what the crops actually need. And so by separating out the liquid, which is often high in nitrogen, then you can have the phosphorus to be more carefully applied as the crop needs. Additionally, as we use it as fertilizer, having a lighter weight manure with less water in it is actually easier to transport to further away fields. There have been studies that show that it reduces odor, especially important as we have more urbanization. It's, again, as I said, as a fertilizer. It can also be composted to make it even more stable or more palatable to sell to consumers as fertilizer. For dairy operations or for confined animal operations, the liquid is actually cleaner now that the solids are removed. And so when farmers flush the walkways and where the animals are staying to clean out the manure, they actually have a cleaner flush with the solids removed. And then finally, it can be used especially well for energy production, or it can be dried and actually used as bedding. And yet, it's not perfect for every operation. For example, it doesn't work well in existing concrete pits and holding ponds that exist on many farms already. So it can be very expensive to buy all the equipment and also have many mechanical problems along the way, more so than simply putting the manure in a pond. And then finally, it does require an additional stage of treatment, which can be something that the farmer does need to manage. This was adapted specifically for swine, and now it's grown for many other operations. Especially in hogs, manure is very high in phosphorus, and so this can be a huge advantage for the environment. Swine manure also is notorious for its odor, and so if we can find ways to reduce that, it's always an advantage. Additionally, though, the liquid can actually be further treated to help to remove ammonia, which is very volatile and can evaporate and cause environmental problems. Swine manure, though, is very fine, and so it can be challenging to sort the manure, and so that's one reason that we've had so many mechanical developments over the years. Smithfield hog operations actually found a way in the early 2000s to sell the manure solids as a soilless growing medium and have actually turned it into a value-added product. On dairy operations, there are many opportunities to use this technology. For example, Dairy manure often is very thick with very fibrous material that can clog drains, but while it clogs drains, it does sort out rather easily and can be used well in the solid liquid separation. Additionally, as you see in the top picture on the left, dairy cows are often bedded with sand or sawdust that can also be very coarse, and it's helpful with this system to sort out the bedding. You have a cleaner flush, as I mentioned before, and then finally, there are major concerns about dairy farms, especially from the EPA in recent years, about their potential to cause excess phosphorus. So if we can find ways to help the environment, we're always doing well. And so many new areas are opening up in this field, and what I'm particularly interested in is the use of flocculants. I interned at a wastewater treatment plant in high school, and the facility that we worked at used flocculants. What they are particles that essentially just make it easier for the manure to clump together. In 2009, Garcia and others published in the Journal of Bioresources and Technology ways that they had used were working to use more natural flocculants for the particles to stick to. What they studied was chitosan, and they found, very interestingly, that it removed up to 95% of the total suspended solids. You can see two pictures here on how much clearer the water is, up to 73% of the nitrogen and half of the total phosphorus. So we can have huge environmental benefits. In the future, more research will likely be done on how to make this more natural and also how to accelerate the growth and care of flocculants. When I was working in high school, we would spend numerous hours every week simply testing to make sure that the flocculants were healthy. Additionally, there's the opportunity to use solid liquid manure separation for energy, because once the solids are separated, it's much more easy to utilize them, and we have the advantage of being able to harvest methane as they're being separated and stored. In 2012, Rico and others published in the Journal of Biomass and Bioenergy ways that they had found to improve removal of methane in storage. They found that 1 kilogram in their laboratory of manure could actually produce 24 liters of methane, which is quite high. Now, 2/3 of that came from the solids in the manure, and 1/3 came from the liquids. But what they found was that although less had come from the liquids, they were able to accelerate how quickly it took for the liquid portion of the manure to process. We're looking at 21 days versus 52. Now, there is a disadvantage that this was done in a laboratory, and thus it can and should be further developed for an actual practical setting beyond a few kilograms of manure. But much opportunity lies in being able to collect the methane from manure with this system. And another area is actually looking at, so how can we best combine the practices? So they looked at coagulant size, and they found that larger coagulants were better at removing nutrients, whereas smaller coagulants were better for energy harvest. They looked at anaerobic digestion, which means the absence of oxygen, that targets different energy molecules and how the bacteria operate. And then finally, they looked at the nutrient value versus the energy production. And so in the future, we'll likely see two trends, and that will probably depend on where the farm is actually located, on whether it's more feasible to apply the fertilizer to the field, so looking at nutrient value and thus a larger flock size, or whether harvesting the methane for energy and thus using a smaller flock size is more helpful. So in conclusion, we have many benefits of solid liquid manure separation, including ability to reduce nutrient pollution and ease of storage, and also many uses for the manure after it's processed. It's not for everyone though, as it's often an expensive system that requires many mechanical components to run well. Although it was first initially designed for swine, it has grown very well and very quickly to be adapted to dairy, and I believe in the future many more farms will utilize this system, especially as farms become larger and have more manure on their farms, it can help to spread the cost. And so in the future, as we look for other research, trends to watch out for are for an increased use of flocculants, more harvesting of methane, and then finally using other systems as the actual combinations, for example, anaerobic. These are my sources that I used for this presentation. Thank you all and have a nice day.